Good morning.
Not too worried about it.
Assume-
But yeah, last time I had windows all over my screen. It was getting a little bit messy, so I'm going to keep it to a minimal this time.
I see. Yeah, I think for now we have more people in the meeting room. Good morning, everyone.
I'm going to go close my door real quick. I'll be right back.
Yeah, sure. So today, Levi will present more about branching and software testing. It's only.
So he probably will talk about branching strategy and then pull requests.
Okay.
And
okay.
yeah, and then the next topic will be coding standards. And I think that's all for now. Yeah,
Okay.
We can talk about testing later.
Yeah, sure.
Yeah, we haven't prepared, but I think we can work on that next.
Would it be all right if I were to also do coding standards today? Because I think that would fit quite well, and then
yeah, that would be perfect, Levi. That would be perfect. Yeah.
Yeah, I think we have 2 sessions left. I think whatever you think is appropriate should be good. Yeah, thanks,
Okay.
Levi.
Were you wanting me to also stop at pull request, or were you wanting me to show a little bit of what I'd found with Jenkins? Because I noticed in the last presentation, the person we had did you say they were from Bloomington? Is that right?
Yeah,
Yes.
Isuru is from Bloomington.
Yeah, I noticed that they hadn't yet gone over Jenkins files, and that's something that it's preference, but I personally find that very exciting for the Jenkins files.
Yeah. How about Levi? So you after you cover the 3 topics, if we have more time, then feel free to talk about anything about Jenkins that you have found out.
I think I can make it fit because what we're going over with coding standards with branching strategies and coding standards today, that's probably going to take up today, and then pull requests isn't going to take up as much time tomorrow, so we'll have a little bit of time to talk about Jenkins. And is he still going to be here tomorrow, or is he just doing that presentation?
Who?
Isuru.
Isuru.
Yeah.
He might join as a guest, so he's not going to present.
Okay, if he does join, he wants to like ask questions or like discuss stuff with me or like what he thinks of Jenkins files, I'd love to talk with him about that. Just hear what he has to say, or if he's looked into it, or he did a wonderful job last time.
Yeah, you did too.
Right. Do we have about everybody in here?
I think only.
If we're waiting on a few people, I'm fine with waiting. It doesn't bother me.
I think pretty much, except Daniel hasn't joined yet, but let me check with him. However, I think let's go ahead and start. This is from Pittsburgh. Morning, everyone.
Good morning.
Good morning.
Good morning. Morning.
Yeah, I have already started the recording, so please go ahead.
Alrighty. Let me clear everything off my screen. All right, today I'll be going over branching strategies and how we'll be incorporating them into Bitbucket and our workflow. Essentially, the objectives that we're going to want to target for this presentation are understanding workflows and how they work, learning different types of branching strategies. We may not go too much into that, but just acknowledge that there's not one good branching strategy. You might want to tweak it a little bit to how your project works and what developers in that group are comfortable with. Learning the branching strategy that we plan on using. Again, there may be some adaptations based on what the developers are comfortable with and how they think they should put it together. That's more up to them and those in a managerial role above them. The master branch essentially is going to be the default branch. It's the main branch when you put together a repository in the first place. The second that you create it, the master branch is made there by default. There is nothing innately, important about the master branch, although people do typically use that as like the main branch that is supposed to be maintained, that is supposed to have essentially only working code. So although it's used in that way, it doesn't have to be. It's just contemporary and it's good practice to have all your good working code in the master branch, which is what ties into this next bullet, which is that source code of every commit reflects a production ready state. For example, if you were to have something in the master branch that had bugs in it, that wouldn't be good. And although that does happen, I'm not saying that it doesn't happen, it does happen. Typically, we will then merge it. We will create a new branch called hotfix. We'll merge everything into hotfix. We'll fix it up in there real quick. Usually it's like a really small problem because that's not supposed to happen in the first place. And then we merge it right back into master. Typically we get rid of the hotfix branch after that. It's just to fix, we just want everything in master to be maintained very well. Where all tagged versions for releases are pulled. So again, reflecting the production ready state. If everything in the master branch is production ready, then we should be able to tag versions for every new release that is in master. Given that we don't have any bugs in it, it should be ready for the user immediately at that point. And there shouldn't be any problems with doing that. This is as opposed to the development branch. The development branch is also called the delivery branch or the integration branch. A reason it's called the delivery branch is when we've got everything finally working where there's no bugs, we can get it pushed off into the master branch where it can be made a release, where we can start to implement it into what the user sees. Essentially, this is what they will be using. But the delivery branch, not everything in the development branch is going to be used by the user. There will be bugs here, there will be problems, and it's expected, and it's not particularly a problem. But when we get past that point where there are no bugs and we've worked everything out, then we can push it off to master. It's also called the integration branch because we will have our own individual, as developers, we'll have our own individual feature branches where we'll work on a feature or we'll work on a very specific topic. And I know I'm getting ahead of myself because I have later slides for this, but we'll have our own features that we work on. And when we finished our feature, or when we think we've finished our feature, then we'll push it off into development. If it happens to have a bug, we still have time to fix it. That's not too much of an issue. As long as it doesn't have a bug in the master branch, we're fine. So long as we have something production ready in master, it's not too much of an issue with having bugs now and then. As long as we have, again, as we talked about with the issue tracker, as long as we have those noted, you know, when we have everything in the issue tracker completed and we think that we've got everything under control and we've had it looked at by peers to check out and see if they can find any bugs, just moving on to master. We've had everything checked by Jenkins. It's all good. Moving on to master. Every commit reflects the last development changes for the next release, which is another important thing. We want to make sure that the features are actually implemented, are actually merged into the development branch before we move it on to the master branch. We don't want to forget anybody's work before we move it on to what the user will be seeing. This is also where any automatic builds are built from. like Jenkins. This will be the branch that we want Jenkins to target. Nothing wrong with also having it targeted in the master branch. If we were to have something later on that we realized that we didn't find, that's good. But Jenkins would specifically target the development branch because this is where we would likely find bugs, where we would likely run into problems. When stable, all changes are merged to the branch above it, which would be master. Merge to release. If not release, then merge to master. The release branch, and this is forked off of the development branch, which is then forked in the master. When finished, this branch is merged into both branches. If there are any adaptations in here, they're likely just minor tweaks to get it off into where the user will see it. Not a lot happens in this branch. It's mostly just there to kind of maintain both the aesthetic and the efficiency of the branching strategy. It doesn't play a huge role. I don't want to say it's just there to be there, but it just makes things a little bit easier having it in the workflow. Shouldn't contain any unstable code. If there are any bugs in the release branch, then typically you're doing it wrong, or you just made a mistake, and mistakes are okay. Mistakes can be fixed, but if it's happening continually, or it's happening a lot, then that's an issue. You don't want to intentionally be putting unstable code into the release branch. Optimally, this will all be checked before. All tests must be passing. As a result, again, we don't want any bugs in the release branch. The feature branches, as I talked about before, these are the branches where we're going to work on our own individual features. Say that, just for example, I'm working on a feature where I'm trying to implement a little box in the UI that shows notifications for the user. This is where I would do that. This is where I would work on that one feature. I wouldn't be working on multiple features in the branch. I would be working on one at a time. And I feel like that might be another problem that some developers can run into. Is they'll get in their feature branch and they'll be working on a bunch of things at one time. And the reason you don't want to do this is that this could cause an issue for testing, because likely if you're doing that, you're not putting as much thought into the test that you're putting together for what you're developing for the feature branch. You want to work on one thing at a time, so that all your focus is on that and making sure that that's working, and not having too many cogs and wheels that you're having to turn at a time. Which is, again, the other bullet. I forget sometimes that I have other things that I've written in here, and I'm saying them before, but yes, focus on a single version of the project in this feature. Again, you can be one developer and have other feature branches. You can have 2 or 3 feature branches, that's okay. But for one feature branch, then just one feature being written in that branch. When the feature is finished, or when you think that the feature is finished, if you're wrong, that's okay. If you happen to notice that there are bugs later, it's fine, that happens. As long as we're getting these tested to make sure they're not going off into the master branch, it's okay if there are mistakes that are made here. But when you think that it is finished, this branch is going to be merged into the development branch, where we're going to do all the testing, where we're going to implement everything that we use with Jenkins. Maybe we have Jenkins files, maybe we just have something monitoring the pipeline from the server. Whatever we're doing with that, this is where we'll do the monitoring in the development branch, and the features just implemented in the branch, merged into development. And after that, we can delete the feature branch. We can leave it there if we decide we want to work on it a little bit more. Maybe we have a working version of our feature, but we're not quite done working on it. Maybe there's more that we want to do with it. That's up to the developer. Whatever they decide to do with that afterwards is it's up to them. It's fine. Hotfix branch, I briefly mentioned this earlier, but this ties into the master branch. This is in the case that we did happen to make a mistake. We recognized a bug later, and we need to get rid of it now, because at this point, it's supposed to be in the production ready state, and the user sees it, and they're using it. And despite that, we have a bug, and we need to fix it here and now. This is typically, this might be what you see in maybe a video game where you're playing and you notice a glitch that, I don't know, you could get like a bunch of in-game currency, but we'll say that the business that owns the game is also allowing real currency to buy this in-game currency. Now we have a problem because we could be losing profit. So this needs to get fixed immediately. We need to get on it now. Optimally, we get this fixed within 24 hours. This is where we're going to merge from the master branch into the hotfix branch, fix everything as fast as possible, and then merge it right back into master and get it out, get a new update ready before it causes too much problems. And we would assert that the players would need this update before playing the game again, such that we wouldn't lose any money on the game. So it's quick patch. This is what this branch is used for. It's forked from the master branch, and then it's going to be forked. It's going to be merged right back into master when it's done. We will also be merging it into the development branch, because the problem that we will have if we don't merge it back into the development branch is likely that we will not think about it. We'll go back into developing, and then when we release it into the project production ready state again, now the glitch is back. And we forgot to merge it into development. So now the players realize that they can do this glitch again, and now we've run into the same issue where we have to copy all the code from the hotfix branch, and maybe we can't because we deleted it. So now we have to go back to master, and we have to find out, okay, what did we do to patch this, because we forgot to merge it back into development. So it is very important in the hotfix branch that it is merged back into dev. It is extremely important. Examples of this use would be an exploited a bug that was found in an application, like what I talked about with money. You know, if your company's losing money, that's not a good thing. You don't want that. Another example would be if a hacker found maybe an SQL injection exploit, and they were able to mess with your database remotely. You don't want that. If you find that, you want to fix that immediately. If you notice that there's any tampering, or you look back, maybe it's in game development again, and you notice that one player, for some reason, has 99 million coins when you've never seen anywhere over 1,000, and then you know you have an issue to patch, and it's likely around that area. The application is unresponsive or breaking. In this case, you know, imagine it would be very important to fix it here and now. This isn't something that can wait, you know, a week or 2 weeks from now. This is likely something that needs to be fixed within 24 hours, if doable. Here I've designed kind of an example of a workflow. Optimally, this is what we would use. Now, before I run the animation, I'm going to give a brief explanation of like some of the things that we talked about earlier and how they're actually implemented into the model. Here we have the master branch. This is the main branch. This is what the users see. This is what the users use. And it's right along this line. It's just going to continue to ride this line. See, now we've made some updates to it. We noticed a bug. We're fixing it here, and we're implementing those changes here. Here we see the hotfix. Notice there is no hotfix here. At this point, the branch has not been developed yet because we've not noticed any mistakes in master. But at this point here, can everybody see the red dot on the screen?
Yeah,
Yes.
yeah, I can see it.
Okay. Yeah, at this point here, we noticed a bug, maybe a game-breaking glitch, maybe something that would allow for an SQL injection or a Nostromus attack or whatever's going on. And we fix it here, and we merge it back into master. Here we have the release. No new releases yet, but at this point, we have something that we could release. We merge it back into master. We merge this back into development. Notice that hotfix is also merged back into development. Here's our dev branch. This is where Jenkins is going to be playing around with the branch. Features are going to be implemented into dev, which are then implemented into release. Implemented here. So I'm going to go ahead and play the animation so you all can see. So we're going from master. We then begin developing our different features. We can have more than 2, but in this one, I just have 2. See, we have the workflow started. We've started merging branches. And see this feature here, we decided that we weren't going to implement it into development. Feature branches do not push directly into master. They push from development to releases to master on their path to the master branch. And versions are pulled from master. Notice up here, if I can get the spotlight again, we have version 0.1, version 1.0, version 1.1. And these are all based off of how relative they are to the quote unquote version of our application that we've implemented. And if you'd like, I can just play this one more time. So you all can see.
Yeah, I can see the animation.
Optimally, this will be very similar to how we'll be implementing our workflow, but again, it doesn't have to be exactly the same, just a similar concept such that you may implement other branches that I don't have in here, but optimally at some point, each of the branches that I have in this image here are going to be necessary. The only one that I would say would not be necessary is hotfix. If you never find a bug in the master branch, you will never need hotfix. In a perfect world, you would never need it because there would never be a bug in master. But in the case that you were to find one, this is where you would use hotfix. Branch permanence. Master and development branch are intended to be permanent branches. They are not intended to ever be deleted. However, you can delete branches. That is something you can do. You can remove the remotes from the Bitbucket repository. You can delete them from your local host. But optimally, you wouldn't do that with master development. Especially not with master. You would likely run into issues if you deleted the master branch. You would make a lot of people angry. But, you know, it's not to say that it'd be terrible if you deleted the development branch. However, this could likely cause problems for Jenkins because we are constantly monitoring this branch with Jenkins. And if Jenkins, you know, you were to make another adaptation, Jenkins goes to look for this branch. If it doesn't find it, it's going to, it could likely tag it as an automatic fail, or you could run into a lot of errors with it. It expects it to be there if you're monitoring it. So you want to keep it there. But as opposed to that, it's not monitoring hotfix or the releases or the feature branches. You don't have to have those all the time. If you decide you don't like a feature that you've been working on, and you're like, I want to get rid of this. We don't actually need this. It would have been nice. I don't really know how to build it, or I don't want to build it, or nobody's going to use it. Just delete it. If you don't like it, you don't have to have it. No, nobody said you had to keep it, unless somebody did, then keep it. But with the release branch, again, that's not something that particularly needs to stay. I would personally keep it, I think, but you don't have to. You know, I would not keep the hotfix branch. if you're doing everything correctly and you're merging it back in development, you're merging it back into master, if those are done and you have done that, you shouldn't ever need hotfix again until you find another problem with master, but then technically it is a different branch. So essentially the point that I'm trying to make is these should never be deleted. If these are deleted, it's not too much of an issue, but keep these in the workflow. After merging two permanent branches, impermanent branches may be deleted without hurting the workflow, essentially. With that being said, you should now be qualified to do the following, which is utilize workflows, implement branching strategies, apply personalized branching, and apply a personalized branching strategy. Now, again, similar to last time, I'm going to take a drink real quick. Hold on. But yeah, similar to last time, although I've talked about all these theoretical concepts with what branching is, I would like to give a more direct and thorough example of how we would actually implement this, if you all wouldn't mind. Is that okay?
Thank you, Levi. This is great. Fantastic.
Yeah.
So we looked at the branching strategies because like in industry, then usually they implement like a branching strategy. And after some discussion, we think that this is maybe the simplest strategy that we can employ in the Cyberwter project.
Yeah.
Like Levi said, you can have a different one, you can have many others, but we're trying to identify a simplest one with the smallest number of possible branches that you want to maintain. And then it will still provide us with a very clear workflow. Yeah, so feel free to ask Levi any questions about. So I think if it's the first time that you are introduced to all the different branches, you might get a little bit confused, like all the different, because usually I can see that without any prior information on this, you probably think, well, I only have one branch, which is the master branch, but that is not correct. Yeah, so understand we at least need the dev branch and the master branch and the difference of these two, and why would we need some other impermanent branches for convenience.
Yeah. I actually wished that I was more familiar with branching strategies when I had first started working with a group when we were using GitHub at the time. It was in CS 222. So I remember we had ran into an issue where we were building our repository, and we ran into a situation where it was kind of similar to where I talked about we would need a hotfix. But the only reason that was the case in the first place was because we never had a development branch. We did everything in master. We didn't really know what we were doing at the time. It was the first time being introduced to Git. Yeah. So we were working on all of that. And I think it was the night before we were supposed to give our presentation on our product. We were doing this nerdy D&D application. But we had done all this work and we put all this work in, and the night before we're supposed to submit this, it all breaks down. Nothing's working. And we're left in a position where we have to do 5 to 6 hours of work at midnight or 11 o'clock at night. And essentially, we had to move everything from making web requests to having the database locally on our machine, which completely changed the structure of the project. And had we done or implemented it in a different way, such that we were doing everything at a development branch, and when it was product ready, we had it released, we would have at least had a release. We would have had something to show, even if it was imperfect to what exactly we wanted. We wouldn't have had to work all night to have something that was product ready. And that was the issue that we ran into. It's like, even though we had tests, we didn't have a product ready, finish.
Yeah, so Levi, when we were working on this in last fall, I think Levi, was it in your third year? Last fall,
Yeah.
when we started working on this, yeah. So
Yeah.
there's a gap like in the soft engineering, like curriculum and what is being practiced in industry. So I think nowhere in the curriculum that you are introduced to this, but this is this is being practiced in industry, like in every company, and there's a reason for that. Yeah. So he was having like having a class in which they have a group project, and we were researching into this, and that's what he explained to you why he found this to be very useful. Yeah, so I think feel free to ask him any questions about the branching strategy. We hope that when the developers they are developing for the Cyberwter project, then we can apply something very similar.
Do we have any questions?
Yeah, so I think Levi, maybe in summary, just remind people what they need to do. Like every developer, they have a feature branch, and then at what time they start off from the master branch, right? And then they fork off their own feature branches, and then after they are done, they merge their feature branches back into dev, and then at which point then they get to they get to interact with the release branch and the hotfix branch. So are there any other questions?
And I have a question.
Okay.
Yeah, so if I wanted to create an issue, so the issue is created on the master branch or is on the other branch?
Okay. Oh, if you were to create an issue, like where would it be? Yeah. If well, it depends on who you are creating the issue. If you are just a normal user, likely you are going to make the issue on the master branch because that's where you're gonna find it. But if you were a developer or you're someone that's helping the developers directly, like as an example, you may be in a position where you can make the issue on a different branch, like the development branch. Likely you are going to make it on master or dev. You would have the qualifications to make it on the development branch, and that's fine. If you're a normal user, you may not have access to the development branch. You may only have access to the features that are being implemented, that are being released to you. So you specifically could make comments and issues on the development branch, and that'd be fine.
Levi, ideally, do you think that the master branch should not have any issues? Ideally,
yes, but probably you're gonna run into a couple. It just happens. No, there's nothing wrong with that. We all make mistakes. It's okay. But you know, it's
so most of the time, I think you can make the issues on the dev branch, because after the dev branch, after all the test cases are run, and then the stable version will be merged onto the master branch. Yeah, so often cases, probably the issue will be on the dev branch, but in rare cases, it can be on the master branch as well. Do you agree? Oh,
okay.
Yes.
Yeah.
Okay. That's a great question. So what other questions do we have here? Are there any confusions about all the different branches?
Yeah, I have a question.
Okay.
Is it possible to only have master and the developer branch?
Is it possible?
Yeah, we ignore the feature branch, release branch, just everyone work on developer branch.
Yeah,
if
you
it's
can have
working, if it's working, then merge it to master.
Yeah, you can absolutely have that. I think it is possible that you'll run into more issues. The reason that I talk about the other branches is it just makes it easier for developers. It's not necessary. Nobody needs it, but it does make it a lot easier, I would argue.
For example, in most cases, we are adding new functions, function 1, function 2, adding more features. We just add them to the developer branch without using feature 1, feature 2. We just add all of them to developer branch.
And that's okay. Yeah, you can do that.
Yeah. And before we release, then we may need a release branch. If we don't,
I think one of the issues that you'll run into though is like, say you were starting to develop a feature and then you realize that you didn't really want the feature in, now you're stuck with it. Now you have to have it. Because you would have to actually go back and manually delete everything. And that will inevitably cause problems. You might delete something that you realized that you needed. It just causes more problems than it does help.
And also I think like it's probably better to keep the feature branches, because for each individual new feature, so that people can work in parallel. So each person focuses on his own feature branch and work on that, and do not push into the dev branch until that feature is complete. And also, like Levi said, if you want to roll over, then roll back, then that's also an option. That's much easier when you have a feature branch.
When do we need the release branch?
The release,
before we release.
When you have everything stable in when everything is stable in the development branch and everything's going good, you don't have any issues, it's product ready, then you can merge. Then you can develop the release branch. Have everything merged into the release branch, and then it goes into you can make minor tweaks in the release branch that aren't going to affect the functionality of the code.
Right. And also, sorry, I also think it's possible that like the reason why you need a release branch, one reason could be like you have all these features merged onto the dev branch, but you can decide which features you want to go into this release. For some features that are already there, you don't want to include them in the current release, then you have to decide to cut it off the dev branch to get a new release branch.
For example, for Feng, for Daniel, for Ran, when they start to work on the GitHub, right now they don't have master developer feature. They may only have master now. In the future, what they should do? So they will fork a developer next.
That's a good question.
I would fork the master branch into a developer branch, and essentially everything that they're usually doing in master, they would just do in developer. So it's like they wouldn't change if you just wanted to use developer, which again you can. Nobody's going to stop you from doing that. It's doable, and people have done it. And I just argue that there are more issues with that. But they would just do everything that they normally do in master in the development branch. And then when they recognize that, okay, everything's how we want it, everything is, all the tests are passing, I don't see any issues with it, I think it's good. And then they would just merge it into master, and we have something that we know is ready to be used. And it's in the master branch. They don't have to change anything that's already in master. If it's already there, it's already there. It's already been done. Don't worry too much about it. But the sooner that you start doing those things in the development branch, the better, because then from that point, everything that you actually find in master is product ready.
Also, how often do we merge developer with master?
Just whenever you can do it, whenever you find it stable.
Okay, when it's ready, when the quality is good enough.
When the quality, when you think the quality of it is great,
Okay.
when you don't see bugs,
Right.
that's when. And you don't have to, but that at that moment, it's a good time to if you want to.
Okay, got it. Okay.
I would advise at any point that you find a stable release, you go ahead and push that off to master.
So the point of all this is to keep your master clean at all the times, if at all possible. Yeah.
Right. I think that's correct. What I think is in the development, branch, you have to pass rigorous testing.
Right.
Whenever you pass all the rigorous testings that you feel comfortable, then maybe it's a time to move it or to merge it into the master. Right. So whenever you merge it into master, you think it's done, at least for now, right? For all those features you have built up, you have built. And unless some users give you feedback, right, or they found some errors or bugs that you have ignored or overlooked.
Then you need a hotfix branch, right?
Exactly. So basically, I think whenever you move or you merge your work from the develop branch to the master branch, the most important thing is that testing.
Exactly.
So that's
so
after you passed all the testings, that's the time you can do it.
Yeah, exactly.
Well, for Jenkins automated testing, so Jenkins will work on the developer branch.
Yep, and it'll be a lot easier. It'll be a lot easier because that's where we'll actually find the bugs. And we could even have, although this is not necessary, if we really wanted to, if Jenkins noticed that everything was passing, Jenkins could just merge everything to the master branch.
So Jenkins can do that automatically, merge it into the master branch. Jenkins can do that automatically, or we need to do it manually, or we can do either way.
Yeah, it's up to you.
Either way.
Yeah.
Okay, that's good.
Do we have any other questions?
Those are great questions. Thank you, Levi. So if we don't have any more questions, I think Levi can move on to the next topic.
Okay. Let me go
please
ahead
go
and close
ahead.
This one right here.
Thanks very much.
You're welcome. Move on to coding standards. All right. Okay, so for this presentation, we'll be going over coding standards and how we'll actually be incorporating them into Cyberwter. From what I understand, from what I've been told, we'll be going over Python, is that correct?
Yes.
Yes, okay, so all the coding standards that I'll be going over today are going to be regarding Python. If for some reason you are to decide that you want to implement other languages or other things for coding standards, notify me, and I'm more than happy to update coding standards to include different languages. But for this time, I've only included Python. So the objectives for today, we're going to be learning new coding standards to improve the readability, legibility of our code, such that the developers would more be able to look at it even at a glance and be able to make adaptations that would be appropriate without any misunderstandings. Understand why certain coding standards are implemented aside from readability. Learn how to apply standards to our own project. That there for a moment so y'all can read it. PEP 8. PEP 8 is essentially the Python enhancement proposal. It is a guide for Python that allows you to optimize the formatting and maximize readability of your code in Python. I did not develop PEP8. I am not one of the developers of the PEP8 style guide, but those who are developers of the PEP8 PEP8 style guide are very versed in Python and have a lot of experience in business and corporations that have introduced these types of styling and formatting and have recognized that implementing this really makes a difference in their workflows and actually implementing code, and makes a difference for those developers that are trying to build off of others' code. It helps large code bases with lots of developers. We don't have that many developers in our project, but despite this, it still helps. But you tend to see a big difference when you're working with, say, 500 or 1,000 developers. You begin to see that it makes a much larger impact because it becomes it's more uniform and it's more predictable across multiple developers. Typically, what you'll find when you're working with a bunch of developers is everyone innately has their own style of coding. Everyone has a certain way that they think that they write their code. You know, a different process goes on in everyone's head. Everybody's a little bit different in how they're going to develop their code. Not all code's going to be the same. But you will, if you implement the style guide, you will be able to make their code a little more similar across different subsections of the code base. And that inevitably allows for different developers that are coming in and looking at this code to be able to build off of it more easily. And in here, I have included a link, and I am more happy after I have finished giving this presentation. I'm more than happy to copy it into the chat or message it to you all, where you can go and check out the PEP8 style guide for yourselves. From what I understand at this point, because it was a little while back before I made this, there may be a PEP9 or later that's been released. I'm not sure yet. I can go check it out, but that's likely for later versions of Python. Because Python is still building. Python 3 is, and I'm more than happy to share this with you or find out if there are later versions of the PEP that have been released. The maximum length for characters, essentially, characters without doc strings or comments in Python should be 79 characters. The reason for this being the default length for most integrated development environments. The default is 79 for PyCharm because PyCharm automatically implements something called Pylint, which is a tool developed for Python that essentially what it does is it automatically recognizes the PEP guidelines and implements them automatically to the best of its abilities. Same default in PyCharm for doc strings and comments is 72 characters. Typically, we want to abide by these. It just makes it easier for the developers scrolling back and forth, trying to read everything that's on the screen. Did I skip anything? No, I didn't. Okay. Line breaks before binary operators are generally not after. It's generally easier for the eyes when you're trying to read through and see what's going on. Typically, this is easier to read, and it will you'll spend less time reading the code as opposed to understanding it and actually implementing it for whatever you need for the project. See, before we have the binary operators put after the variables that we have for this income variable. But afterwards, I've moved the binary operators to go before the next set of lines of variables. If it needs to be this long, this is optimal on multiple lines. This is optimally how we'll have it implemented if it has to be this long. Imports. Optimally, we will want to import separate modules on different lines. Although Python allows you to import on one line, this is typically good for scripting, and it's intended for scripting. If we're writing something for a program, a full-length program, we're going to want to move that OS down to a second line. That way, if we were to scroll to the top and we want to see what modules we are importing or what we're using at the time, especially because we can have multiple of these on one line, we don't want to re-import something twice or do anything that may affect the time that we're using to run the code. And depending on the size of the package that we're importing or the module that we're importing, it can take a long time if we're doing it twice, which is an issue if you're putting it on multiple lines like this. However, same module imports may be made on the same line. For example, if we're saying from subprocess import poppin, which subprocesses say we are trying to run shell commands and we're trying to get the outputs of them. We don't particularly need to say then on another line from subprocess import pipe. We can have these on the same line because we know they come from the same package. So it's not as difficult to understand when we're going up to scroll to the top and see what all we're using there. And in certain circumstances, PyCharm, which I've been informed is the IDE that you all are using, this will also notify you of that as well as it implements Pylint. You want to avoid unnecessary white space inside syntax brackets, parentheses, and braces. See, and here I have decided to implement small spaces in here. And although it looks nicer, we were going to want to achieve something more that looks like this, where I have minimized that white space between the brackets. And here in this tuple, where I have the comma here. And for those who are familiar with syntax of tuples, if you just put it inside the parenthesis without the comma, then it's just going to say foo equals 0, as opposed to foo equals the tuple of one item, which is 0 at index 0. Operator padding. Operators in a statement with varying priorities may merit white space around those with lower priority. The reason that we want
Hello, seems we lost your voice.
Yeah.
Levi?
Right, I cannot hear anything anymore.
Yeah, so maybe there's an internet problem with this connection.
I am having an.
Yeah.
Can you hear me now?
Yeah.
Oh, yes.
Okay. I got a notification that I am having a bad internet connection. Did I cut off on the last slide or on this slide?
On this slide, just like the beginning of this slide.
Okay, I can start it over then. That's not a problem. Operators in a statement with varying priorities may merit white space around those with lower priority. The reason that we want to do this is for readability. We could manually go through and recognize which operators are going to be implemented before the others. However, we can use white space to our ability to help the person that's reading our code recognize automatically which is going to be implemented first, and it looks somewhat like this. Notice the difference between the two. Now, if I turn the spotlight, we can recognize, for example, here, we're doing the multiplication before the subtraction. Now, I'm not to say that somebody who's developing would automatically know this, but it is easier to read and easier to look at. We automatically can assess, okay, I know that this is going to be happening first. And it's just a difference between the styling. We've not changed anything with the code or the functionality of it, but yet we can already see that there's a difference in how we read it, as opposed to if I were to go back, you know, it is easier to read and it is easier to assess that in a shorter amount of time. We want to treat colons and slices as binary operators, as mentioned before. See in here. Slices, and some of these, for example, the double colon here, I would argue that some of these may be harder to understand and may even be unnecessary at this point for anyone who is unfamiliar with some of the syntax of Python, because not all of it is actually necessary for, you don't need to implement some of this into the code, but this was something that I found in the PEP 8 standards that may be helpful for those of you that are Python gurus and like to like to read into complex syntax like I do. I'm more than happy to share some of these slides with you so you can look them up in the PEP 8 and how to implement them and such, but this slide isn't as much necessary. There's just something that I found that was nice for slices and binary operators. Brackets and assignment padding. White space padding is also not recommended for dictionaries or indexing and should be spared around assignment operators. See in this, I have spaces here and here before the key, dictionary key and the list index here. And something that we would see maybe in earlier versions, maybe an older C code, or maybe if you like me read older assembly code, I know not everybody does that, but you'll see a lot of that white space where they want to line up these equal signs in their code. However, according to the PEP 8 and helping with readability, again, if you were wanting to skim through this while still maintaining a general understanding of how it works, you want to remove this white space. Annotations padding. Function and method annotations should have proper white space padding. Now, what annotations are, and I feel like I might want to give a brief explanation as to what this is, because not everybody knows what this is, because it was implemented in Python 3.6. So for anyone that's had a lot of experience in Python 2.7 or previous versions of Python 3, you may not be familiar with annotations. What annotations are, if I can get this here, here we have annotations for, essentially this is a class. So we're asserting that this is going to be an object of this class that we're going to be passing in as a parameter. You can compare this to what we would be doing in Java. The only difference is that these annotations are not required. However, they are highly suggested for developers that are going to be reading the code later. Here we have an annotation for what is going to be the returned class object of this function. We know that it's going to return a type that is a positive integer here. And we know that we will be passing in an any string object into this munch function. The munch function doesn't do anything. It was just a randomly selected name for the function. Here we are defining complex, and we have this image set as a default to 0.0, which is default selection for this Python function. And here we are specifying we are specifying the type that is going to be passed into this parameter and what its default value is. And here we have the default object that's going to be passed in and the default value of this. I want to recognize the difference between this. We are padding these with white space in here. It does improve the readability of the code. And then secondly, in this area down here, I can get it to move on. There we are. We are removing white space for default values and padding the white space here. These are things that, although I do not typically understand why they do this, they've found that it does improve readability. And those that want to implement it into development have, I'm trying to find the word, but it makes overall improvements in the code. Whoops. Here, notice when we have the annotation here and we're also assigning the default value, we want to pad white space around it. And for this down here, sorry, annotations and anything that would be set default to none. This is important. This is very important because certain values that are set to none, although they will be set to that by default, we want to actually explicitly say that in code. Boolean conventions and lambda expressions. I'm unsure if we are going to be using any lambda expressions in the code. However, if we are, these are the PEP 8 standards that we're wanting to abide by. We're going to want to use the is not operator as opposed to not is. If not foo is none is less readable than if foo is not none. The latter tends to roll off the tongue better, and for anyone that is actually physically reading the code, this is better. It will achieve the same conditional. The Boolean value is going to be the same. It's not going to change the functionality of the code. Most of what I'm going in here is not going to be changing the actual functionality of the code, but it will change how the developers may interpret it and how long they will be spending reading this. Same for using the define statement instead of the lambda expressions. It is highly suggested that you use definitions as opposed to lambdas. Even if you have to do it on one line, you still have the availability to be able to do it on one line without having to implement a lambda. Now, personally, you know, I did personally have a problem with this just because I enjoy using lambdas. However, they are correct in saying that using a definition will improve the overall experience of the developers as opposed to preference. My preference was lambdas. No. Always catch bare exception clauses as opposed to a bare except clause. See, we're asserting the import error here. Now, although I did say earlier that this does not affect the functionality of code, this is one of the exceptions to that, because a bare exception clause will also catch system exit and keyboard interrupt exceptions, which can instantiate other problems. I don't know if you all are familiar with, if you were to say Control-C out of it, or whatever, that would be the example of a keyboard interrupt. You can close Python programs that you are currently running by hitting Control-C. This may override that because that is labeled as a keyboard interrupt exception. So at this point, while it is implementing this part of the code, it will recognize that accept and not allow you to actually close out of the program while it's running. Similarly, with if you were trying to exit the program in this block, it will not allow you to do that because you are accepting that system exit. Error handling code reduction. You want to limit code contained in try catch statements to avoid essentially bug masking. So here we have try to return the handle value of a collection with this key passed into collection. And we're going to accept a key error where we're going to return that the key is not found for that key that we have been passing into collection. Essentially what we want to do is we were going to try that the value is equal to the collection with that key being passed in. Return key error, key not found key, else return the handle value. And I'm going to go back and forth just a couple times so we can go over this one because it is a little more complex. Essentially what we're going to be doing is we're trying to get around this, this being passed in to this function that's then going to be returned. So we're returning down here. We're trying to reduce what's being implemented into the try and accept, or for those more familiar with Java, try catch. Return statement consistency. You want to maintain consistency in return statements. Although this would be by default returning none, again, does not change the functionality of the code. Reading it as a developer, we then recognize if we were to get a none, now we know why. Whereas before we may be a little bit confused because we would be expecting a float to be returned. However, this may explain why we're getting a none. If it's not greater than or equal to 0, now it makes sense. Boolean comparisons and built-in workarounds. You don't want to compare Boolean values to true or false if greeting is equal to true. Reason being is that we can just say if greeting is true, but the Boolean value of it is already going to be true. So we don't need to implement those equalities there. It's the same as saying if greeting, and that minimizes the amount of code that we have to have there. Trailing underscores are preferred to leading underscores when trying to avoid Python keywords. An example of this may be class. You cannot use class as a keyword because we use this as a Python keyword when we want to say class box, and then we define the initialization of the class and such. But they prefer that you use the underscore afterwards as opposed to before. Again, improving on the readability of the code. Now we're going to very shortly go over naming conventions. For functions and methods, you want to use a lowercase word or words separated by underscores to improve the abilities, to improve readability. Say function, my underscore function, class underscore method, and these are for functions and methods. Variables use a lowercase single letter word or words, separate words with underscores to improve readability. X bar my underscore variable. You are allowed to use single letters for this if the situation allows it. Start each word with a capital letter for the class do not separate words with underscores. For classes, essentially camel case classes, I would assume that everyone in here knows what camel case is. I'm not going to go into that. Constants use an uppercase single letter word or words. Separate words with underscores to improve readability. I would assume everybody knows what constants are as well. Modules use a short, lowercase word or words, separate words with underscores to improve readability. If there happen to be spaces in there, those are going to be underscores. Packages use a short, lowercase word or words, do not separate words with underscores for packages. Naming convention violations, you never want to name variables essentially L or O because these letters can be confused with ones or zeros, which may cause confusion later on. You never want to name functions or variables, etc. the same as Python built-ins or imports, such as class, int, or sleep if you are importing from time. It is highly advised that common imports like from time import sleep are not used as variables because they can then override things that you may have imported earlier. Never name the files the same as a module that you are importing. This is something that I have seen all too common in Python development, where essentially somebody is saying, all right, I'm going to write an example file where I am going to practice stuff with time. So you're going to name your file time.py, and inside that file, we're going to say import time, and we're going to kind of try to understand how the time module works. And what you'll find is that you're just going to get a bunch of errors, going to have a bunch of problems, and you aren't going to understand why. Well, it's because you named your file time.py, and what you're importing is time.py. So what you're trying to do, what Python is trying to do, is it's trying to import itself, and it's having a lot of issues. So you want to avoid that. And I give, again, this exact example that I was just talking about. Doc strings. All functions and methods should be documented with multi-line doc strings, including parameters and returns. There is no blank line either before or after the doc strings. They should be updated regularly to match the functionality of the code when it is documented. If you are updating code that has doc strings in it, afterwards always make sure that you are updating the doc strings to match what you have edited inside that block of code. And here I have another link that I'm more than happy to share with you all that goes more into depth on that. And that should be all for this presentation. You should now be able to do the following, which is understand how to improve the readability of your coding standards. Understand how some standards improve more than just the readability, as we've covered earlier. Especially in the case of except statements, you may also be masking hidden bugs. And understand how to apply these standards into your own project. And that should be all of that for that presentation. Do we have any questions?
Thank you very much.
Yeah. Thanks.
Thank you, Levi. This is fantastic.
Go ahead.
I have one question. Is the doc streams, you mentioned when people change the interfaces, they usually also need to change the comments in the doc stream to express the explanations of this API. So does it have to be done manually, or the IDEs, like the PyCharm you mentioned, does it automatically detect your interfaces have changed, so it will give you a notice you need to also change the doc stream?
Yeah, yes, I do recognize that there are automatic implementations that say the PyCharm IDE will be able to, I think you were mentioning that the IDE that you all are using for Python that is able to make automatic adaptations to the docstring. Is that correct?
Yeah, I don't know what, I'm not sure because previously when I handle my code to run, I think I changed some interfaces, but I forgot to change the comments. So it might, it can be really helpful if the IDE have those things.
Yeah, I know PyCharm can make some adaptations. Most of what the adaptations that it makes, from what I understand, are more to say you added another parameter to the function. I think you could hit Alt Enter, and there's an option that you can use for docstrings, or maybe it's a different set of key combinations. You could probably Google it and find which that is. But it will allow, it will add that other parameter in as a option, but it doesn't make adaptations for like what is this function intended for. It doesn't have any understanding of its performance, or say, for example, what the developer intended to be passed through and what they intended it to be returned for. And I think those would be good things to update manually after you finish writing that block of code. Just so later developers can come in and look at it and be like, oh, okay, I know exactly what this does, instead of, you know, maybe spending 10 to maybe 5 minutes kind of reading over it and being like, okay, what does this do? It really depends on how big your function is. I don't know exactly what functions or methods you're talking about. If they're relatively smaller, may not be much of an issue, but say you have like a 25-line algorithm, that might be something that you would want to update the documentation on.
And, yeah, I have another question. So, like, the coding style you mentioned, like PEP 8. Do people usually enforce the coding style in one of the branches, or people actually check whenever you push to the GitHub?
I wouldn't say that anybody is going to particularly check the coding styles. The coding styles are essentially something that are, because again, it doesn't change the functionality. The coding styles are something that are implemented more on you as the developer, where it's your responsibility to implement them, as opposed to somebody else to enforce that you're doing it. It's more of a service that you're doing to the other people that are looking at your code, not because you're required to do it. No.
Those are great questions. Like the coding standards is more like for any new developer that is being introduced into the development team, then they need to be informed of the existing coding standards. And then all the existing developers, they should read about this and then apply the same coding styles. And then like another thing, like especially when the code base becomes larger and larger. So I think like the doc strings for writing the documentations for every function or method, that becomes very important. Yeah, because basically for every function that is not trivial, then you need to document what is the major functionality of that method or function, and then what are the input parameters, what are the output parameters, what are the return values, yeah, and things like that. And then maybe, so these comments, you probably need to manually update those doc strings as you update your code. But later on, like after you leave this project, you graduate, and then when other people pick up your job, then this documentation will be very helpful for them to pick up from the existing code base. Yeah, so these are more like things that we agree among our development team. Yeah, if we try to apply the same coding standards, if we try to apply the same styles, then it will help the maintenance much easier down the road.
Yeah, I remember when I was going over with Dr. Lin for the first time, and she was telling me that she wanted me to put together a presentation for this. At the same time, I was a teaching assistant for Python and Java programming. And I was working with a lot of students, and as I was going over this, I thought about it, and I said, although they are being introduced really to programming for the first time, I feel that this is something that may be able to help them, and I encouraged the students to implement these annotations and coding standards, and I found that the students that implemented them when they were working in group projects were able to achieve more features and get more done in a shorter amount of time than those who did not implement the annotations or incorrectly implemented them, or simply did would try to implement them but didn't actually really I don't want to be rude, but didn't read up on how they were actually supposed to be implemented and just kind of threw some stuff together. But those who actually put effort into implementing these coding standards, I saw a better performance in their groups than those who didn't.
It's very good information. Thanks for sharing.
Mm-hmm. Thank you, Levi. So do we have any other questions for these two topics that Levi presented today? Yeah, I just wanted to thank Levi because I think he spent a lot of time doing like we spent some time going back and forth. So for every topic, then there's several versions of the PowerPoint slides, and he actually spent a lot of time doing the animations to make this easier for people to understand. Yeah, great job, Levi.
It's very good.
Thank you.
The presentation is really clear.
Yeah, Levi. Yeah, good, very good job, and I think everybody has learned a lot from your presentation. And so tomorrow, I know that you have the last topic, so maybe we will have some time after you finish your tomorrow's planned topic. So please feel free to talk about the jacking, whatever you would like to talk about, because I think that's very important.
Right.
And so Isuru touched about it, but it's like Dr. Lin said last time, it was on the high level. Yeah. So I think we need to learn much more in detail about Jenkins.
Right.
Yeah, I'll try what I can to dumb it down a little bit, but the unfortunate fact about Jenkins is that just in and of itself, it is very high level and it can be very complex, and it is very hard to dumb down, and it took me a lot of time to actually understand how it worked. Dr. Lin remembers when we were first working with it, I got very frustrated.
Right, exactly. So, thank you, Dr. Liang, and thank you, Levi. So let me add some comments to that. So Levi is very smart and very independent. So we worked on these topics together, and he did most of the work. And like when I first hired him to work on this, he was so excited about all this. He was so excited about Jenkins. But then we realized it's not that easy. So Jenkins will be the next big thing, huge thing that we are going to attack. So he got started, but we do not have a quite comprehensive idea about what that is and how we are going to use it. So I told him we try to filter out because it's huge. So we'll try to filter out things that are not very important to our project. We'll try to pick up like the minimal set of things from Jenkins that we're gonna use. Yeah, so we didn't plan to talk about Jenkins at this set of tutorials, but we plan to do that in the future. But I think tomorrow Levi can maybe give some introduction on what he already found out. It might not be that everything we know about it, we can answer like all the questions about it, but it's more of an exploration process.
Yeah. I'm not a professional, but I'm getting there. I'm getting there. I'm learning.
Yes, yeah. So he's getting there. He was very frustrated at the very beginning, because we are all new to that, and then he has nobody else to discuss this. So I was hoping that Isuru, if he's available, then they can have a conversation about some of the confusions Levi might have. But
Yeah,
right.
oh, sorry.
So maybe, and I don't know if it's possible. Sorry to interrupt. And then Feng Guang or and then you can invite Shuru back tomorrow to discuss more of the Jenkins in terms of. I'm really interested in and testing. I think, like Yao mentioned earlier, that is really very, very important. And only you cannot push all the codes into the master branch as until you have a thorough layers of testing. And so the like, for example, unit testing and performance testing, functional. I think most of the students right now in Daniel, Zan, and Feng, they have done a good job, very good job, in testing on the unit testing and performance testing to some extent, because otherwise their code won't work. But then we need to also test to have like statistic testing or automatic testing. In like Yusuro showed very briefly last time a couple of screens where you can monitor how the code is doing and what are the things that are missing. And if you just do the unit and performance testing, because you know what you are looking for, and then you test those. And there are always the cases where you overlooked something or missed something, and then if you don't do those automatic testing thoroughly, and then there can be a high risk of or high chances of having bugs. So if that is possible, and if Levi have some time to focus, I know you just learned it, and like Dr. Ning said, but if you can spend more of your time to focus on that, like automatic testing and performance testing, how to use the Jenkins to help us on that, that will be very great, helpful for the development teams.
That's very good suggestion, Dr. Liang. So I think that's what Levi and we can do next as a next step. One is Jenkins, the other is how to do testing for the Cyberwter project. We'll look at all the different levels of testing. Go ahead, Levi.
Sorry to interrupt.
Go ahead.
Also, I also got a message from Isuru. He will join us tomorrow. So
that's great.
Oh, right on.
That's great. And yeah, so from that's great. So the tell Isuru that we are going to have more discussion about the Jenkins. So we wanted to have his voice on that.
Thanks. I will also.
Thank you.
He seems to have been using it for a while, so and so he can give us more insights from.
I think the discussion, you know, the Levi and the Isuru, they have maybe have a different perspective. So that's why we wanted to discuss together. That way, everybody can learn something.
Exactly, that will.
That would be great.
And down the
to contact him right away.
And down the road, I think when Levi is ready, because we are still learning that, it's a gigantic thing. But when Levi is ready, then we are going to give another set of tutorials just on Jenkins.
That will be great. So this is just the first step, like you said. So Levi will talk about what he learned so far, and of course we will have the future one, which when Levi is completely ready. So in that time, it's not just Jenkins, it's like you said, it's about other testing methods that we are going to use. So we will first say what the Jenkins can bring to us, and then we'll see what beyond that, what we can do.
Right.
Sounds great. A good plan. Thanks.
Thank you. Thank you. So is that all for today? I think. Okay. So so we can meet again tomorrow. For the remaining topics.
Okay.
And Feng, the link is the same one, right?
Yeah, it's the
Yes.
same like today's meeting number.
Okay. Sounds good.
Okay.
Thank you very much.
no
Thank
problem.
Levi and Dr. Lin very much for
Oh,
this great work.
Oh, you're so welcome, Dr. Liang. Thank you, Levi.
Yeah, thanks for sharing.
Yeah, Levi did a lot of the hard work.
Yeah.
Fantastic job, Levi.
Yeah, especially Levi is an undergrad, and so that is very impressive, Levi.
Thanks.
Good job.
Yeah, I picked him when I was, for the very first time, like last fall semester, I was assigned to teach an algorithm class, and I picked him before the midterm when I found
You
out
have
he's
good eye, Dr. Lin.
Thank you.
I want to thank Feng
Yeah.
very much for all the organization work. And
Right. So
Yeah,
Feng
no problem.
you are a good host, Feng.
Yeah, thanks.
Oh,
Thanks.
yes.
Yeah,
Yes.
you work very effectively in this regard.
Right,
Yeah.
right.
And
Thank
also,
you.
I think Zanda and Feng asked very good questions, and so that makes the discussion more interesting, you know.
Yeah.
And so all the students here are wonderful, and so we are very happy to have you guys
Right.
working with us.
Right.
Thank you.
Thank you.
Yes,
Thank you.
thank you all.
That's
Thank
good.
you.
I hope
Bye-bye.
tomorrow.
See you tomorrow.
Yeah. I
Yeah,
hope tomorrow
bye.
you have a lot of good questions too. Thank you.
Yeah, thanks. Bye.
Thank you. Bye.
Thank you. Bye.
Bye.
Bye-bye.
Bye.